Hello everyone, Dr. Polaris here. Despite being one of the three major lineages of dinosaurs, the Ornithischians have a rather poorly understood and controversial early history, whereas definitive members of both Sauropodomorpha and Theropoda have been uncovered from late Triassic deposits. Potential Ornithischian remains from the same period are either completely absent or simply have poor rates of preservation. Despite this, phylogenetic studies have consistently found that these herbivorous dinosaurs had almost certainly diverged during the Triassic, perhaps by around 230 million years ago. For many decades, the oldest and most basal putative Ornithischian was considered to be Pisanosaurus, from the late Carnian-aged Ischigualasto Formation of Argentina. However, considerable debate has surrounded the classification of this small, slender herbivore, with some studies arguing that Pisanosaurus was not even a crown group dinosaur, but instead a Silesaurid. These lithe, leggy herbivores were native to the late Triassic and somewhat resembled graceful reptilian deer, often walking and running quadrupedally. Traditionally, they were positioned as being highly derived dinosauromorph archosaurs, forming the sister group to Dinosauria. However, some more recent studies have found that Silesaurids may have been true dinosaurs after all, in particular being stem Ornithischians. This would go some ways to explaining the lack of Triassic fossils belonging to this lineage, with Pisanosaurus representing a transitional form between the more basal Silesaurids and unambiguous Ornithischians, such as Eocursor and Lesothosaurus. One of the earliest well-known families of these herbivorous dinosaurs were the unusual Heterodontosaurids. Although, as I'll explain later on, the exact classification of these animals is also somewhat unclear. First appearing during the early Jurassic, roughly 200 million years ago, Heterodontosaurs were a widespread group of small bipedal herbivorous or perhaps omnivorous dinosaurs, the remains of which have been recovered from all continents except Australia and Antarctica. The most readily identifiable trait of these animals were their characteristic heterodont teeth, which was an unusual feature among non-avian dinosaurs. The ancestral condition for the family seems to have been the presence of three premaxillary teeth near the tip of the upper jaw, with the third of these being enlarged and fang-like. A similar yet larger caniniform tusk was also present near the tip of the lower jaw. Meanwhile, the cheek teeth of basal Heterodontosaurids were quite similar to those of other small Ornithischians, although in more derived forms these were chisel-shaped and high-crowned, forming interlocking tooth batteries well adapted for chewing vegetation. Many of the oldest Heterodontosaurids have been uncovered from South Africa, including the well-known type genus Heterodontosaurus itself, native to what is now Cape Province during the early Jurassic between 200 and 190 million years ago. This animal was the largest known member of the family, reaching up to 1.75 metres or 5 feet 9 inches long, and weighing 10 kilograms or 22 pounds. Being about the size of a red fox. Known from multiple, at times well-preserved specimens, Heterodontosaurus possessed a relatively small yet robust skull, large eyes, as well as proportionally elongated and well-muscled forelimbs that were roughly 70% the length of the hind limbs. These were possibly utilised in digging up roots and tubers, or perhaps even for burrowing. Its unusual teeth have led to suggestions that Heterodontosaurus may have been an omnivore that fed on insects and small vertebrates in addition to plant matter. Although recent studies have compared their diets to those of modern peccaries, which have similar tusks yet feed on tough vegetation, the caniniform teeth were probably utilised for processing food, although may also have filled defensive or display functions as well. The genus was endemic to the dry, semi-arid Upper Elliott Formation, alongside the small Ornithischian Lesothosaurus, the bipedal sauropodomorph Massospondylus, which was the most common dinosaur in the formation, as well as the relatively large Dilophosaurus-like theropod Dracovenator. In addition to these were three other Heterodontosaurid genera, including the more basal Abrictosaurus, which measured about 1.2 metres or 3.9 feet long, and possessed lower crowned and more widely spaced cheek teeth than in Heterodontosaurus, with the forelimbs also being notably shorter in comparison. This indicates a different ecological niche for Abrictosaurus, with this animal probably feeding on softer vegetation. Other members of the family present here included Lycorhinus and the distinctive Pegomastax, which possessed an unusually robust and deep predentary, producing a beak that was almost parrot-like in appearance, Pegomastax was the sister genus of the younger Manidens of the Cañadón Asfalto Formation of Tahuaquén, Argentina, between 179 and 178 million years ago. Known from multiple fragmentary specimens, Manidens was a tiny animal that measured just 60 centimeters or 2 feet long and weighed a mere 500 grams or 18 ounces. Interestingly, it's been hypothesized that this genus may have been somewhat arboreal, given that associated hind feet reveal long toe bones that were capable of grasping, with tests finding the feet and toes to be comparable to those of modern perching birds. Other heterodontosaurs of a similar diminutive size include Fruitidens, from the late Jurassic Morrison Formation of western North America, native to the brushy basin member of Colorado circa 150 million years ago, and known from the remains of at least 4 specimens of different ages. This tiny Ornithischian reached adult sizes of up to 75 centimeters or 30 inches long, and weights of between 500 and 750 grams. This is comparable to a modern pheasant in mass. In addition, the jaws and teeth of Fruitidens were notably more generalized than those of the significantly earlier Heterodontosaurus, indicating a broader diet of softer plant matter, as well as possibly including invertebrates from time to time. By the late Jurassic, Heterodontosaurids had also spread to East Asia, including the spectacularly well-preserved genus Tianyu long, endemic to what is now Liaoning Province, China, during the Oxfordian stage of the late Jurassic circa 158 million years ago. This animal is known from a near-complete holotype specimen that preserves impressions of fuzzy integument over the base of the neck, along the back, and above the tail. These structures are rather simple and unbranching, with the living animal appearing to have a fluffy fur-like coat. The presence of such structures in an Ornithischian led to debates regarding the origin of dinosaurian pelage, with some researchers arguing that protofeathers, or bristles, were an ancestral trait for all dinosaurs that were later lost in certain lineages such as the sauropodomorphs. However, it's not clear whether the protofeathers of theropods and the fuzzy or bristle-like structures found in Ornithischians were homologous, with it being possible that both groups evolved these features independently. Regardless, it's highly likely that given their small body sizes and active lifestyles, all heterodontosaurs possess similar coats for the purpose of insulation. As of 2026, we know of only one member of this family that persisted into the early Cretaceous, with this being the genus Echinodon from the Berriasian stage of the UK and possibly France. This was probably the smallest of all heterodontosaurs, with fully grown adults measuring an estimated 60 centimeters or almost 2 feet long. It was first named by Sir Richard Owen all the way back in 1861, with the animal initially thought to have been a herbivorous lizard. Living in a warm lagoonal environment with a climate comparable to the modern Mediterranean, Echinodon may have been a relict insular form, explaining its status as the youngest known Heterodontosaurid. After this point, the group vanishes from the fossil record for reasons that are not well understood, with competition from more derived Ornithischians perhaps being a factor, although this is very difficult to prove definitively. However, that's not all I have to say about these fascinating little herbivores. As mentioned earlier, the classification of Heterodontosaurids is still debated by paleontologists, with the general consensus view being that these animals were very basal Ornithischians. On the other hand, a minority view holds that Heterodontosaurids are actually basal pachycephalosaurs, given some similarities in tooth and skull structure, particularly the presence of fang-like caniniform teeth. If this is true, it would explain the lack of Jurassic pachycephalosaur fossils in contrast to their ceratopsian cousins, although this would also push back the origin of marginocephalians, as well as the ornithopods, all the way back to the early Jurassic circa 200 million years ago. This seems somewhat improbable to me, with most phylogenetic studies indicating that marginocephalia diverged by around 170 million years ago, 30 million years after Heterodontosaurids first appeared. The similarities between these groups is probably due to convergent evolution instead. Thanks for watching, everyone. The next episode will be covering T-Rex. No, not that T-Rex. This one. The recently described and massive Tylosaurus rex, the largest mosasaur so far known, which should reach up to 43 feet long. See you again soon. Cheerio.